is Phil Lambert, and I'm going to give a short demo of Fortify's printer portal, which is a significant component of the Flux developer toolkit that Fortify provides to our customers that allow them to develop their own material configurations to run on the Fortify Flux Core and Flux Series line of 3D printers. So first thing we need to do is log in. What we're logging into here is a browser-based organization within that anyone within an organization has access to, provided that they have a sign-in and an account created, where users can view all of the material configurations that the organization has created. And the material configuration, which are listed here with unique IDs created times, configuration names, and some other metrics. These are configurations that control which parameters will be used on a specific material when you're printing on the machine. So this includes things like the amount of energy you're providing to each layer, how quickly the build head moves, what temperature settings you have inside your resin, and other parameters like that. So the first page you come to before we build a material configuration is your existing material configuration. So right now we have 2 existing material configurations that were generated as part of a demo. And if you want to look at them, you can expand. And in this expanded screen, we have the ability to review all the configuration parameters that we currently have set. They're currently in 4 different categories. CKM settings, which stands for continuous kinetic mixing, which is a set of configurations that controls how the resin is circulated, how it is heated. The second is our peel settings, which control your layer height most significantly, but also some other values here relating to how high you peel, to what height you peel during a wiper pass, different print head speeds for during the peel, and then some other values here as well that control the wiper frequency and speed. After the peel comes the plunge. So similar values here. We're controlling the rate at which we plunge and the force with which we plunge. And finally, we have our UV settings, which controls the dose and the UV intensity and some other metrics that we use to control how much energy goes into the layer for each build, for each configuration. So we want to make a new configuration. We come up here to this plus button, and we're allowed to name our configuration. So we'll name this one Demo 2021-08-18. And we have this really nice option to load from existing configurations. If we want to make just small changes but want to hold everything else constant, we can do that. We're not going to do that today. We're going to start from fresh. And so in CKM, which is, as I said earlier, is our continuous kinetic mixing module. First thing you have to do is select your mode. This gives you the option to use CKM, which is circulation of the resin and heating of the resin. Or alternatively, if you want to print in a classic DLP style with a reservoir only, no heat, no circulation, you can do that too. All of those parameters disappear, but we're going to set them today. I want to set my CKM speed, which is the RPMs of a peristaltic pump. Set them at 100 RPMs for that pump. The resin target temp, we'll set it to 100. I did that on purpose to show you that there are some limits that we've built into this tool. So the machine can't set a temperature above 80 degrees C. So we'll set it to 60. And then an aux loop wall temp is required. We'll set that to 80. We'll always want this value to be higher than this value because this is the maximum heater temp. So the resin will be going to short excursions up to 80 degrees C in order to heat, but controlled to be 60 degrees C with the current settings here. Next, we have the peel settings. So we have a variety of settings here. These are really important settings. Peel height, which is how high you're peeling off the build platform. Set that to 7 millimeters. Peel height during wiper pass. This is typically a constant around 12 millimeters. Depends on the height of the wiper. Slow peel speed, which is the peel of the peel speed prior to your part separating from your film, which is the substrate that the light passes through to cure the part. So we want to have this be pretty slow. We'll put it to 20. And then fast peel speed is a peel speed after the part separates from the film, so there should be no real impact on the part because the part at this point should be fully separated from that film substrate. So we'll crank this up because we want it to go really fast in order to save build time. We have the ability to set some layer heights here. We can't go below 35 right now. We can't go above 1,000 microns. So we'll set it to a reasonable layer height, 100 microns, thickness of a single layer. Ramp time, which is a metric that controls acceleration. I'm not going to explain it right now, but we'll set that to 15 seconds. And our wiper frequency is how many layers between a wiper pass on the substrate. Typically somewhere in the order of 2 to 10, sometimes up to 20 layers if you don't have a resin that sediments out very quickly. Our decent wiper settings, and then wiper speed. Again, it really depends on your sedimentation rate, and it can be optimized here. We'll set it to 30 millimeters per second. We have the plunge values now. These are the values that control how the build plate returns to the substrate to prepare for the next layer. So we got the plunge speed, which will set something similar to our peel speed, and we can set it a little bit higher. Control overshoot, which is how far past the target layer height you're controlling your plunge to. This is something that you sometimes do if you want to really accelerate your build. You never set it too high. We'll set it to 1 micron. Again, another acceleration value, set it to 15 seconds. And plunge force threshold, which is a threshold at which the system understands the plunge action to be complete. Usually when you plunge, your force during your plunge spikes and then it normalizes, and usually 15 newtons is a pretty good value. So once the force measured by the build plate returns to 15 newtons, the machine recognizes that as the end of a plunge, and then we'll start curing. And finally, our dosage values, something in the order of 50 milljoules is pretty typical for a photopolymer. An intensity of 10. I just want to show you some limits here. So looks like we can't go above 20, so we've got a limit here. We can't go above 20 milliwatts per centimeter squared. We'll set it to 10. So burn-in dose is the energy at the first layer for adhesion to the build plate. We'll set that to like 200 millijoules per centimeter squared. And then burn-in transition layers are the number of layers between your initial burn-in dose and your nominal dose. Sort of a ramp down, just so you're not going from so you don't have a dramatic change in your energy from one layer to the next during your burn-in. Typically 5 to 10 is what we use. So when we're finished there, we review. Similar screen as before. We're just making sure all of our settings are correct. And we'll hit save. So now that that is saved here, it's got its unique ID, a time during which it was created, its name, its creator, and its status. So I haven't really talked about status yet, but status is an important metric here. So these configurations, when they are active, will all get pushed to the Fortify Flux series printer and become an active material configuration that the user can select to run a print. But sometimes when you run 1,000 experiments and you have 1,000 different material configurations, you may not want to cycle through all those configurations. You want to keep your user interface clean on your Flux series printer. Come up here and you can retire a configuration. All this does is it changes the button to retired. This configuration no longer shows up on the UI of the printer and is not selectable, but is still here for posterity for your historical reference. And you also have the ability to go in and activate it if you want to use it again. So that is the material configurations development tool in the Fortify printer portal. Thank you very much.